Alright, this is Algebra, section 11-5, and we're dividing polynomials, okay? There is a concept that I want to reacquaint you with, and that's rational expressions, but I want to simplify it to a certain extent here. If I had the quantity 6 minus 4 and all over 2, okay, I can rewrite that as 6 over 2 minus 4 over 2. Okay, 6 over 2 would be 3, 4 over 2 would be 2, and that gives you 1. And if you look over here, 6 minus 4 is 2, 2 over 2 is 1. So you get the same answer. So you can break up a rational expression with a common denominator. Alright? That's going to be key for what we're doing. Alright, this section we're dividing polynomials by monomials and binomials, okay? Example 1 here is on page 601. And let's do him together. Alright, so we have the quantity 3r squared minus 15r, okay, and we're dividing that by 3r. Now, previously what you did was you keep it, change it, flip it, and work it that way. And you're going to find that that's not as useful. What we are going to do now is rewrite this as a rational expression. So we're going to have 3r squared over 3r. Well, let me write the whole thing out, sorry. 3r squared minus 15r, and all that over 3r. Now what we can do is break this up into a common denominator where we have 3r squared over 3r minus 15r over 3r. Alright, and so out comes the pen. We love to cancel, right? So we have a 3 and a 3 that can cancel. We have an r downstairs that will cancel with one of the r's up here and leave that with just r to the first. Over here, 3 goes into 3 once, 3 goes into 15 5 times, and the r's go away. And so what you're left with is r minus 5 over 1. Okay? Or just r minus 5. Now, that's one way to do this. Alright, now you can actually go through and have done this a different way, starting with our friend right here, 15r all over 3r, and then from what we've done in the last section, we can factor out a 3r from the top. If you factor out a 3r from 3r squared, what's left is r. And if you factor out a 3r from 15r, you're left with a 5. And that's all over 3r. So these will cancel, and you're left with r minus 5. So this is yet another way to do this. Okay? So let's go down here, pause the video, and give yourself an opportunity to try B right here. Okay? Okay, we're back. Hopefully you did try this on your own, and we'll go through it together right now. So we have n squared plus 10n plus 12, and that's all over 5n. Okay? Now, if you factored this polynomial on top into its factors, you're going to find that that doesn't help you at all. So you have to break this up into fractions over a common denominator. So n squared over 5n plus 10n over 5n plus 12 over 5n. Okay? We can cancel, right? Our favorite thing to do. Yay! So the n here cancels with the squared up there and leaves you just n. The 5 here cancels with the 10 and leaves you 2, and the n's cancel. And 12 over 5n, well, there isn't anything you can do with that, right? Right. Okay. So what are you left with here? You're left with n over 5 plus 2, because everything else canceled in this middle term, plus 12 over 5n. All right. You're going to find that that's the answer. And that's the answer that they list in the answer key. Okay? Now there will be problems where that may not be the only form of answer. In other words, if you do it a different way, you can come up with an equally valid answer. But it is going to be on your hook to determine that your different answer is numerically identical to the answer in the book. Okay? Otherwise, go back and work the problem the way they want you to get the answer in the form that they have it in the answer key. All right? Clear as mud. Do things the book way. Leave your originality. If you want to be original in your solutions, great. But it's on your shoulders to prove that your solution numerically matches the answer key. Don't just go, yeah, okay, clip, and away we go. Moving on. All right, so now what we have here is we have a polynomial being divided by a binomial. So we have s squared plus 6s minus 7. And that's all over s plus 7. All right, well, let's factor this guy and see what we get. So what two things multiplied together give you negative 7 and added give you positive 6? Ponder that for a second. S and S. Well, I hope you came up with. Okay. And then on the bottom, s plus 7, which if you haven't figured it out by now, that's a big hint of what your factors should be, right? The bottom. Okay, we can cancel because we love to cancel. And that gives us an answer of s minus 1. And we're going to move on. All right, long division. I'll bet you weren't even aware that you could use long division on polynomials. But you can. Long division works whether the polynomial can be factored or not. Okay? This is our example here. We have the quantity x squared plus 3x minus 24 being divided by x minus 4. All right. So we're going to take this a step at a time. Okay, so here is step 1. We're going to write this in long division form. So we have x minus 4, and that's going to go into our number, polynomial here, x squared plus 3x minus 24. So we look at this and we say, how many times can x go into x squared? Well, if you look up here, basically x squared divided by x is equal to x, right? So we put an x right here, and then we multiply this through, like we would normally do for long division, okay? So x times x gives us x squared, and x times negative 4 gives us negative 4x, okay? And then what you do in normal long division is you subtract this term from the top. So x squared minus x squared gives you 0. 3x minus negative 4x will give you positive 7x. Then you bring down the minus 24. Okay? So x goes into x how many times? Well, it goes into it 7x. Well, actually, that's step 2 now. Okay. Okay, so x goes into 7x 7 times. So 7 times x gives you 7x, and 7 times negative 4 gives you minus 28. Okay. Now you have to subtract this as a binomial. So 7x minus 7x is 0, and negative 24 minus negative 28 is negative 24 plus 28, which gives you a positive 4. Okay? So just like in long division, this is a remainder because x can't go into 4, right? 4 is a constant. There are no x's in this term right here. So we have a remainder. Therefore, our problem up here is equal to our answer here, x plus 7 plus 4 over the divisor. Okay? That's the answer. Long division form. X plus 7 plus 4 over the quantity, x minus 4. Alright? Now, does that look useful at all? Where you're at mathematically now, not so much. But that still is a useful mathematical term when you get into engineering or in science, okay? So the fact that it looks weird, and doesn't look nice and neat does not mean that that's not a good answer. All right. So polynomial long division is still a technique that's used in the real world. All right. So moving on to our last one here. What would you do if you had terms that were missing in the polynomial? Okay. So if you look, our polynomial has an a cubed and then an 8a, and there's no a squared. All right, so you handle this like so. You take the a2, or a minus 2, okay, and that's going to go into this polynomial, a cubed. Now, is there an a squared term? Or an a squared term? No, so you go plus 0, a squared. You put in a 0 for a placeholder, and then you're left, you have 8a and then minus 24. All right. Okay, so you look at your binomial out here and you say a. How many times does a go into a cubed? Well, a cubed divided by a is equal to a squared, right? So over the a squared term, we have a squared. And then we take a squared and multiply it through our binomial. So a squared times a gives you a cubed. And then a squared times negative 2 gives you minus 2a squared. All right? So you are subtracting this whole expression. So a cubed minus a cubed is 0. 0a squared minus a negative 2a squared is a plus 2a squared. So you have a positive 2a squared. And then you bring down your next term. Okay? Plus 8a. So now we look at it and we say, how many times does a go into 2a squared? Well, it goes into it 2a times, right? So 2a times a gives you 2a squared, and 2a times negative 2 gives you minus 4a. And you're going to subtract that whole expression out. So 2a squared minus 2a squared is 0, and 8a minus a negative 4a gives you a positive 12a, and then you bring down your last term, minus 24. Okay? How many times does a go into 12a? Well, it goes into it 12 times. So 12 times a is 12a, and 12 times negative 2 gives you minus 24. And remember, you're subtracting this whole expression. So 12a minus 12a is 0. And negative 24 minus a negative 24 turns into negative 24 plus 24, which is 0. Okay? So then your solution is a squared plus 2a plus 12. Okay? That's it for this section. If you have any questions, please email me, and hopefully you've watched the video to the end so I can give you golf ball head. Okay. Yes. We all love golf ball head. So be sure to email me, like it if you like it, comment it if you can, and I will see you next time. Bye.